No one can deny that the famous Kalashnikov assault rifle, for all its undeniable advantages, also has a number of hard-to-fix flaws. Let's start with what seems like the smallest one, the inconvenient design of the safety selector lever. Those who know the history of this rifle remember that on its first experimental models, known as the AK47, both the fire mode selector and the safety were located on the left side of the receiver. On that model, the safety, much like on Kalashnikov's 1943 submachine gun, was engaged and disengaged with the thumb of the right hand in a pistol style, which was very convenient for a right-handed shooter. However, what was not convenient was, first, the separation of the fire selector and the safety, and second, the location of the selector itself. It was out of reach for the thumb, so switching fire modes required using the left hand, taking it off the forend. But by August 1947, for the final stage of the competition where the Kalashnikov competed against the Bulkin and Dementiev assault rifles, a different prototype was presented, one that had little in common with the AK-47. It was this prototype, not the one adopted in 1949 and indexed as the AK-47, that served as the basis for the serial production model. And on this experimental model, we see the now iconic combined safety fire selector lever now located on the right side of the receiver above the trigger guard. The main advantage of this design was that this single lever, serving as both the safety and the fire selector, also blocks the bolt carrier from being pulled back. Additionally, in the safe position, it acts as a dust cover, protecting the ejection port from dirt and debris. But the location of this lever makes it impossible to use without taking your right hand off the pistol grip. Moreover, this safety selector is notoriously stiff to move between positions. Of course, for those who handled well-worn training rifles, this stiffness might not seem like a big deal. But if you are issued a new, factory-fresh combat rifle, switching it off safe requires a lot of force. This often causes the lever to skip past the full auto position and go straight to semi-auto. If you actually wanted full auto fire, you'd have to move it back up one notch. Interestingly, this design and placement were considered successful and even copied in other weapons until the very beginning of the 21st century. Just remember the famous SVD sniper rifle. It was only in the 2000s and more widely in the 2010s that aftermarket improved safety selectors from small private companies began to appear. These were used for tuning standard AKS and their foreign copies. For the AK-12, designers initially tried to return to a scheme similar to the AK-46, with ambidextrous fire control controls on the first version. But by the 2016 version, the familiar finger-hurting lever was back, though now with a finger shelf. It wasn't until the 2023 version that a similar lever was duplicated on the left side with a pistol-style fire mode selector. The next flaw, which many ironically call an advantage, is the magazine attachment system. This method was invented by Alexei Ivanovich Sudayev. It was on his intermediate cartridge assault rifle, presented in the 1944 competition, where this magazine type was first used. It's still used on Kalashnikovs, as well as weapons like the Cord and Abakan. This magazine has a lug on the front and a support lug on the rear. It's inserted into the rifle in two stages. First, you hook the front lug onto the front edge of the magazine well in the receiver, then you rock the magazine's rear end towards the rifle until the magazine catch clicks, engaging the rear lug as it slides into place. The problem isn't so much that this method is inherently slower than a straight-in insertion, but rather a common statistical failure. In the heat of battle, a shooter might fail to properly hook the front lug. If they then rock the magazine, the catch will still engage the rear lug, but the magazine becomes jammed at a skewed angle. This situation is reversible, but fixing it takes precious seconds, seconds that in combat can cost a life. But the most criticized flaws of the Kalashnikov since its inception are its relatively low accuracy, and even more so, its poor precision. The main reason for low accuracy in semi-auto fire is the short sight radius, only 378 millimeters. For comparison, the M16 has a sight radius of 501 millimeters. The Kalashnikov's potential sight radius could have been 575 millimeters if the rear sight was placed on the very back of the receiver cover. But that cover is removable, and the rifle would have to be re-zeroed after every field strip. As for the poor grouping, there are two reasons. The first is that the angle of the stock doesn't align with the recoil vector. This angle is designed for a comfortable cheek weld, but because the recoil force and the counterforce from the shooter's shoulder are misaligned, it creates a twisting torque upon firing, making the barrel jump upwards. Because of this barrel jump, you have to reacquire your sight picture after every shot, even in semi-auto. In full auto fire, the bullet dispersion becomes huge. To fix this, the AK has even been converted into bullpup configurations multiple times. After such conversions, precision improves slightly, but only a bit. That's because a more significant factor causing dispersion wasn't neutralized. The weight of this component is 477 grams for the AK-74 and 520 grams for the early AK and AKM models. That is the weight of their bolt carrier group, which includes the bolt carrier, the bolt, and the gas piston. So, after every shot, this roughly half-kilogram mass first moves 138 millimeters backward, then 138 millimeters forward. If the rifle isn't locked in a vise, this movement makes the muzzle climb when the BCG moves back and dip down, nosedive, when it returns forward. To reduce this effect, the creators of the AK-12 decided to lighten the bolt carrier by drilling multiple holes in it, a practice already common among private tuning companies. In 2011, they managed to reduce the mass of the moving parts this way, making it even lighter than the 240-gram bolt carrier group of the M16. But the designers likely forgot that this flaw is the flip side of the AK's main advantage: legendary reliability. This reliability, specifically in feeding the next round, was ensured by two things: the large mass of the BCG and its long travel. The kinetic energy of any moving body is defined by half of its mass multiplied by the square of its velocity. The greater the mass and speed of the returning bolt carrier group, the more energy it has to strip a cartridge from the magazine and forcefully chamber it. But since the mass of the BCG, which kinetic energy directly depends on, was reduced by 2.13 times, the force available for chambering was reduced by the same factor. Consequently, when the initial AK-12 model went for testing, it started experiencing failure to feed malfunctions one after another. This, of course, wasn't the only flaw of the early AK-12, but I will try to cover all its advantages and disadvantages in a dedicated video.